Now evaluate this function, limit of this function. Say here, limit z tends to 1, z raised to 1 by 3 minus 1 upon z raised to 1 by 6 minus 1. This is given. Now here if we keep z equal to 1, then denominator will be 0. Numerator will also be 0. Now if you observe this pattern, then you can find here matching with this form. X tends to a, x raised to n minus a raised to n upon x minus a. You can find pattern of this function, this form in this question. Say here in the denominator, this is not z minus 1. Here x is variable. Here z is variable. So to get this form, what we do? Here 1 can be expressed as 1 raised to 1 by 3. 1 can also be expressed as 1 raised to 1 by 6. Now to get this form, we divide numerator and denominator by z minus 1. And now you can see that this pattern is obtained in numerator as well as in denominator. Now limit of fx upon gx is limit of fx upon limit of gx. Limit of fx upon gx is limit of fx upon limit of gx. Now by this rule, this is equal to n times a raised to n minus 1. So here this is n, 1 by 3 is n, variable is z, constant is 1 is like a. So by this rule, n times a raised to n minus 1 upon here again this rule, but here value of n is 1 by 6. Here there is 1 by 6, 1 by 6. So put here 1 by 6. So 1 by 6 times this is a, 1 by 6 times a raised to 1 by 6 minus 1. So this is 1 by 3 upon 1 raised to anything is 1. Here 1 raised to anything is 1. So value is 6 by 3, that is 2. Now here say this function is defined by if x is less than or equal to 1, then it works by this formula, and if x is more than or equal to 1, it works by this formula. Here function is changing its value at 1. Function is changing value at 1. If x is less than or equal to 1, for all these values of x, fx is x square minus 1, and for all these values of x which are more than 1, fx is minus x square minus 1. Function is changing its value at 1. Function is changing its formula at 1, and we are asked limit at 1. So if function changes its working formula at a number at which if you are asked limit, then check left limit as well as right limit, because here when x tends to 1 from left side, then all x will be less than 1. In that case, we have to use this formula. And when x tends to 1 from right side, then all these values of x which are on this side, it will be more than 1. So in that case, we have to use this formula. So here we find left hand limit of fx. X tends to 1 from left side. X tends to 1 from left side, that means x is coming near and near towards 1 from left, means x is coming towards 1 from this side. So here all values of x are less than 1. And if x is less than 1, then x is less than 1, fx is x square minus 1. Reason, because x is less than 1. This means x is less than 1. Now, putting here x equal to 1, then we keep here 1. So 1 square minus 1, that is 0. Now we find the right hand limit. Limit of fx, x tends to 1 from right side. X is coming towards 1 from right side, but that means x is coming towards 1 from this side. X are coming from this side towards 1. So this side, when x change its value, all x are greater than 1, because all values will be on the right side of 1. So this means x is more than 1. This means x are more than 1, and if x is more than 1, fx is minus x square minus 1. Now putting here 1, so this will be minus 1 square minus 1, that is minus 2. So you can see now here that left hand limit and right hand limit as x tends to 1 are not same. So here limit of fx, x tends to 1 from left side, is not equal to limit of fx, x tends to 1 from right side. This is left hand limit, this is right hand limit. So therefore limit of fx, x tends to 1 does not exist. Now here find a limit of fx, x tends to 0. At 0 we want limit of fx. Fx is modulus x upon x if x is not equal to 0, and 0 if x equal to 0. Say here fx equal to modulus x upon x at 0. This means x not equal to 0, here x equal to 0. Now here see, again I am expanding this form. That means fx equal to, here see, when x is positive, x non-zero, that means x can be positive or it can be negative. So if x is more than 0, then modulus x is x. This will be x. Modulus x is x if x is more than 0, and modulus x is minus x if x is less than 0. So this is expanded. Mod x is x if x is more than 0, and mod x is minus x if x is less than 0. X is not equal to 0, it means x can be positive, x can be negative. If x is positive, put mod x equal to x. If x is negative, put mod x is minus x. This statement as it is. So that means fx equal to, we are getting this formula in simple form. This is 1 if x is more than 0, minus 1 if x is less than 0, and 0 if x equal to 0. Now keeping this simple form of function in mind, we are finding limit. We want to check at 0. At 0, function is changing its formula. See here, at 0, function is changing its formula. So, first of all, we find a limit of fx as here we did. At 1, at 0, here in this question at 1 it was changing formula. Here at 1 it was changing formula, here at 0 it is changing formula. So, limit of fx, x tends to 0 from left. See, when x is coming towards 0 from left side on number line, here there is 0. When x is coming towards 0 from left side, all values of x are less than 0. So, x is less than 0. X tends to 0 from left side, means x is coming towards 0 from left side. In that case, x is less than 0 and x is less than 0. So, fx equal to minus 1. Fx is minus 1. This is constant function. And this is a free from x. If you find here x, then put x equal to 0, but it is free from x, it is constant. So, limit of constant is constant. This is constant, keep as it is. Now, we find limit of fx, x tends to 0 from right side. Say this was left hand limit, now we are finding right hand limit. At which number? We are doing at 0. What happens if x tends to 0 from left? What happens if x tends to 0 from right side? When we find individual limit, if at this number function is changing formula, then we do this method. Now, right hand limit. X tends to 0 from right side, means x is coming towards 0 from this side. When x is coming towards 0 from this side, that means all x are positive. So, all x are positive. And if all x are positive, then value of fx, fx is 1. If x is more than 0, fx is 1. So, I keep here 1. And now, we put this value in this expression. But this is constant function free from x. So, limit of constant k is k. If this is constant, it doesn't depend on this number. Whatever number is given here, if this is constant, keep as it is. So, this is 1. So, see, left hand limit is not equal to right hand limit. So, here, therefore, from 1 and 2, it is clear that limit of fx, x tends to 0 from left, is not equal to limit of fx, x tends to 0 from right side. So by definition, at 0 limit does not exist. Therefore, limit of fx x tends to 0 does not exist. Find the limit of this function as x tends to 0 and find limit of this function at 1. Now look here, function is changing formula at 0. So for this case, we will find left hand limit as well as right hand limit. See here, at 0 function is changing formula. If x is less than or equal to 0, means on this side, if x is less than or equal to 0, fx is 2x plus 3, and on this side, if x is more than 0, fx is 3 into x plus 1. Now say here, at 0, if x is less than 0, this is formula. If x is more than 0, this is formula. And at x equal to 0, we want a limit. So let us find left limit as well as right hand limit. So limit of fx, x tends to 0 from left, it is equal to limit x tends to 0 from left, x is coming towards 0 from left side. This sign indicates left side, not a negative. So x tends to 0 from left side, that means x is less than 0. If here number 3 is given, that means x is less than 3. If here 5 is given, x is less than 5. To the left of 5 means x is less than 5. X negative. If x is negative, fx is 2x plus 3. Now putting this value here, 2 into 0 plus 3. See, whenever we keep value of x in expression, we don't write this lim, limit. This symbol we do not repeat. So continue this symbol till you get the simplest form of function. Now this is 3. Now we are finding right hand limit. Limit of fx, x tends to 0 from right side. If x is coming towards 0 from right side, that means these values are more than 0. This means when this is happening, x is more than 0. X is coming towards 0 from right side, that means x is more than 0. And if x is more than 0, this is fx. So in this case, fx is 3 times x plus 1. And now I put here value. When we keep value, don't repeat lim, limit. Put value. So 3 into 0 plus 1, that is 3. So see, equal. So here, therefore from 1 and 2, if we say this is 1, this is 2, from 1 and 2, it is clear that limit of fx, x tends to 0 from left, equal to limit of fx, x tends to 0 from right side, both are 3. left hand limit is equal to right hand limit and it is 3. Therefore, limit of fx, x tends to 0, it is 3. Now, we are asked limit at 1. Limit of fx at x tends to 1. Now see, at 1, see on number line, here this is 0 and after 0 here 1 comes. Somewhere here there is 1. That part I am showing here. Here 0, here 1. This is x more than 0. For x more than 0, fx is 3 into x plus 1. For these values, fx is 3 into x plus 1. In this interval, if x is more than 0, then fx is 3 into x plus 1. Now look here, at 1, when x tends to, now we are discussing at 1. If x tends to 1 from left or if x tends to 1 from right side, when x is changing its value from left of 1 or from right of 1, that means x lies either in this side or in this side. So, in both the intervals, x is positive. So, in both the case, we will use this formula. So, here, first of all, left hand limit. When x tends to 1 from left side, if x tends to 1 from left side, then see, x tends to 1 from left side, x is going near and near towards 1 from left side, so x takes values from 0 to 1. So x belongs to 0 to 1. And if x belongs to 0 to 1, that means x is obviously positive. And if x is positive, so formula for fx is 3 into x plus 1. So putting here 1, 3 into 1 plus 1, that is 6. Now we find limit of fx, x tends to 1 from right side. When x is coming towards 1 from right side, means x is coming towards 1 from this side, so x are more than 1. So here, when x is coming towards 1 from this side, x is more than 1. X tends to 1 from right side towards 1 from right side, coming like this. So all x are more than 1, and if x is more than 1, obviously it is positive. Every value more than 1 is positive. So x positive, so same formula, 3 into x plus 1. So here at 1, on left of 1 or on right of 1, function is not changing its formula. So we use same formula. So this is 3 into 1 plus 1, it is 6. So from 1 and 2, we say this is 3 and 4. From 3 and 4, it is clear that left hand limit is equal to right hand limit. So from 3 and 4, it is clear that limit of fx, x tends to 1 from left, is equal to limit of fx, x tends to 1 from right side, equal to 6. Both are same. Therefore, limit of fx x tends to 1 is also 6. Suppose that function fx is a plus bx if x is less than 1, it is 4 if x equal to 1, and b minus ax if x is more than 1, and limit of fx at x equal to 1 is f of 1. What are possible values of a and b? Say here we are given limit of fx x tends to 1 is equal to f of 1, and f of 1, what is f of 1? F of 1 is 4. So f of 1 is 4. Limit of fx is 4. So that means limit of this function exists at x equal to 1 and it is 4. It means left hand limit will also be 4 and right hand limit will also be 4. That means limit of this function as x tends to 1 from left will be 4, as well as limit of fx x tends to 1 from right side equal to 4. If left hand limit and right hand limit are equal, then we say limit of that function is 4. So limit exists and it is 4, it means this will be left hand limit as well as right hand limit. Now x tends to 1 from left means x is coming towards 1 from left side. So all x are less than 1, and if x is less than 1 we use this formula. So here I keep a plus bx, a plus bx, and if x tends to 1 from right side means all values are more than 1, and if x is more than 1 we use this formula. So here I keep b minus ax. Now putting this limit, putting x equal to 1 here, a plus b into 1 is 4, and putting x1 here, b minus a into 1 is also 4. So a plus b is 4 and b minus a is also 4. So we solve these equations. Adding these equations, minus a plus a will be cancelled. B plus b is 2b. 2b is 8. 2b is 8. That means b equal to 4. And putting b equal to 4, a is 0. Putting here b equal to 4, a is 0. So therefore a is 0 and b is 4. Now in this question, see here, this expression, it contains a hidden pattern of this standard form. This is hidden in this question. To get this form which is hidden in this expression, what we do? I am taking substitute. I am taking x plus 1 equal to y. Taking x plus 1 equal to y. It means we are changing this variable. New variable is y. New variable y. So everything now we are converting in y. X plus 1 is y. So x will be equal to y minus 1. So here we will keep y minus 1. So limit is x plus 1 is y. So y raised to 5 minus 1 upon x is, when x plus 1 is y, what is x? Y minus 1. 1 can be expressed as 1 raised to 5. See, we are getting that pattern. But variable is y. So we should convert here in y. X tends to 0 as x tends to 0. If x is coming near and near towards 0, put here 0. So y will be 1. So y tends to 1. So put here y tends to 1. Don't forget to change this limit. As x tends to 0, y tends to 1. See, everything in new variable. And now we can apply that formula. So by this rule, this is 5 times 1 raised to 5 minus 1. So value is 5. Say here, putting this in simple form, fx equal to, this is mod x plus 1, x less than 0, 0, x equal to 0, mod x minus 1, x more than 0. Putting this function in simple form, x is less than 0. If x is less than 0, modulus x is minus x. X equal to 0, this 0 keep as it is. If x is more than 0, then mod x is x. Say we are using definition of modulus. If x is more than 0, modulus x is x. If x is equal to 0, then also we can say modulus x is x. If x is less than 0, modulus x is minus x. This note we are using. So mod x is minus x. Modulus x is, here modulus x is minus x because x is less than 0. And modulus x is x because x is more than 0. Now, function is changing formula at 0. So always keep doubt at 0 where function changed its formula. So let us check limit at 0. So limit of fx, x tends to 0 from left side. If x tends to 0 from left side, that means x is less than 0. If x is less than 0, fx is minus x plus 1. Putting here 0, this is 0 plus 1, so left hand limit is 1. Now right hand limit. Limit of fx, x tends to 0 from right side. When x tends to 0 from right side, that means x are more than 0. If x is more than 0, then we are using this simple form. X is more than 0, put fx is x minus 1. So here, putting here 0, this is 0 minus 1, it is minus 1. See, left hand limit and right hand limit are not equal. Therefore, limit of fx, x tends to 0 from left is not equal to 0 from right side. So this function limit of fx x tends to 0 does not exist. Limit does not exist at 0. So this was discussion at 0. So here, if a is 0, then limit of fx x tends to a does not exist. And if this number a is any non-zero, therefore if a is any non-zero number, here a limit does not exist only at 0. For any non-zero, then limit of this function exists. So for every non-zero, limit exists. Now here, say given that limit of fx minus 2 upon x square minus 2 x tends to 1 equal to pi. This is given. It means limit of this function exists. Limit of this function exists. This is the meaning of this statement. Limit of this function exists and it is pi. Now look, here putting x equal to 1, denominator, limit of denominator is 0. Here limit of x square minus 1 x tends to 1. Check denominator. Putting here x equal to 1, its limit is 1 square minus 1 equal to 0. So because this is 0, this must be also 0. Therefore, limit of numerator as x tends to 1 equal to 0 is must. Because the limit of this function exists and limit of a denominator is 0, so for existence of this limit, limit of a numerator must be also 0. And this is possible if limit of fx x tends to 1 minus limit of constant equal to 0. Limit of fx minus gx is limit of fx minus limit of gx, individual limit. Therefore, limit of fx x tends to 1 minus, now limit of constant is constant. If here you are given constant, keep as it is. Whatever number is here, limit doesn't depend on this number if this is constant, equal to 0. Now minus 2 take on that side. So limit of fx x tends to 1 is plus 2. So that is required value. If for this function fx equal to mx square plus n if x is less than 0, nx plus m if x is between 0 and 1 including both numbers, and fx is nx cube plus m if x is more than 1. For what integers m and n does both limit of fx at 0 and at 1 exist. Say here function is changing formula at 0 as well as at 1. There are two numbers at which function is changing formula. First of all, we discuss this case. For existence of limit fx as x tends to 0, for existence of this limit of fx x tends to 0 from left equal to limit of fx x tends to 0 from right side. This is required. At 0, limit exists if left hand limit equal to right hand limit. Because at 0, function is changing formula, and wherever function changes formula, find left limit as well as right hand limit. So therefore, that is, now limit x tends to 0 from left side means x is less than 0. X is less than 0, so use this formula mx square plus n equal to x tends to 0 from right side means x is more than 0. X is more than 0 is here. X is more than 0, so use this formula. That is, now putting x 0 here, m into 0 square plus n equal to n into 0 plus m. That is n equal to m. That is m equal to n is required. For existence of limit of function at 0, this is required. Now second part, similar discussion for this function. For existence of limit of fx x tends to 1, for existence of this limit of fx x tends to 1 from left equal to limit of fx x tends to 1 from right side is required. We are discussing at 1, and at 1 also function is changing formula. That is, limit x tends to 1 from left side, x is coming towards 1 from left side means x is less than 1, and when x is less than 1, use this formula. This side x tends to 1 from right side means x is more than 1, so use this formula. This is for x more than 1. So that is, putting here 1 n plus m equal to, putting here 1 n plus m, which is true for every number, every integer m and n. This is true, which is true for every integer m and n. That means for every integer m and n, this limit exists. Limit of fx x tends to 1 exists.